In number 1, we have the function y equal 2 to the x minus 2 minus 8. And we want to find the domain range, xy-intercepts, horizontal asymptote, and graph. I think we'll start with graphing. So what we're going to do is translate y equal 2 to the x, and we're going to move it to the right 2, and because of the minus 8, it would be down 8. And that would give us the graph of y equal 2 to the x minus 2 minus 8. All right, so let me quickly draw y equal 2 to the x. It goes through 0, 1. It goes up on the right. And on the left, we have this horizontal asymptote at the x-axis, so y equals 0. So we're going to be moving this picture. First of all, right 2 and down 8. So 0, 1, let's see where that goes. Right 2, we're going to add 2 to the x-coordinate. And for down 8, we're going to subtract 8 from the y-coordinate. 1 minus 8 is minus 7. So let's first translate this point, 0, 1, to 2 minus 7. So let's do that. 2 minus 7. Okay, so there we go. And it's also important to translate this horizontal asymptote. This is y equals 0. So the x-axis is y equals 0. So that's the horizontal asymptote will be translated down 8 units to y equal minus 8. So here we have minus 7. Here's minus 8. Okay, so this is y equal minus 8. So that's going to be our new horizontal asymptote. That's what we were asked to find right here. So let's draw this picture. Okay, so we have the curve goes through this line, and basically it increases. And on the left, we have this horizontal asymptote. And somewhere in between it's going to cross, in between minus 7 and minus 8. Here's minus 8. It's going to cross the y. It's crossing the y-axis. And then up here somewhere it's going to cross the x-axis. So let's see what this point is. That is the y-intercept. So we're going to set x equal to 0 to find the y-intercept. All right, so let's do that. Let's find that here. So to find the y-intercept, we're setting x equal to 0. So let's do that. So we have y is equal to 2 to the 0 minus 2 minus 8. That's 2 to the minus 2 minus 8. 2 to the minus 2 is 1 over 2 squared, so that would be 1/4. 1/4 minus 8. 8 is 32 over 4. So if we subtract, we get minus 31 over 4. All right, so this point over here is 0, minus 31 over 4. And it's a little bit above minus 8 on the y-axis. All right, what about the x-intercept? Let's figure that out. Let's say we do that over here. So to find the x-intercept, we set y equal to 0. All right, in this equation. So we have 0 is equal to 2 to the x minus 2 minus 8, or moving the 8 over, 8 is equal to 2 to the x minus 2. Now we're going to match the two bases. Here we have base 2, here we have base 8. So we're going to change this to 2 cubed. So that way we can have the same base on both sides. Once we do that, then we'll set the exponents equal to one another. 3 is equal to x minus 2. So we have x is equal to 5. All right, so right there at the crossing point, we're going to indicate that the crossing point is 5, 0, x equals 5 for the x-intercept. All right, so we found the horizontal asymptote. That's y equal minus 8. We found the x-intercept and the y-intercept. Let's just do the domain and range. Looking at the graph, this arrow is going to go is going to continue all the way to the left, and this one goes up, but as it goes up, it goes to the right. It continues to the right. So the furthest to the left that the graph goes is minus infinity, and the furthest to the right is plus infinity. It's going slowly to the right. It's going up quickly, but as it goes up, it goes slowly to the right. So the domain is x is between minus infinity and infinity, basically all real numbers. And for the range, this graph does go up to infinity. The range would be, say, how far up and how far down the graph goes. So the graph goes all the way up to infinity, but it doesn't go all the way down. It stops here at minus 8. So the range is y greater than minus 8. The graph of y equal e to the x looks very much like y equal 2 to the x. Remember that e is approximately equal to 2.7. And the graph is very, very similar. It's going to go through 0, 1, and that's because e to the 0 is equal to 1. And it's going to increase pretty quickly on the right. And on the left, it goes down and gets closer and closer to the x-axis. So we have a horizontal asymptote here. If we want to put in another point, say when x is equal to 1, y is equal to e to the 1. So the graph also goes to the point 1 comma e to the 1. Okay, so let's look at the domain. So this graph will continue to the left, and here it continues to the right. It goes up quickly, but to the right slowly. And so the domain will be all real numbers. And the range, okay, so now we're looking at the up-down direction, how far up the graph goes and how far down. Well, the graph goes up to infinity, we see here. And we see the graph does not go all the way down. It stops. It stays above y equals 0, the x-axis, which is y equals 0. So the range is y greater than 0. The same as the domain and range for y equal 2 to the x. Okay, number 3, we have a compound interest problem. And let me write down the formula for calculating the amount that's invested at a certain interest rate that's compounded. So here's the formula. The amount after a number of years is equal to the initial amount, that's P, times 1 plus the yearly rate divided by n, which is the number of times the interest is calculated, or the number of times it's compounded per year. And in the exponent, we have that same n times t, where t is the number of years. All right, so let's see what we have here. Here we have an investment of $1,000. It's invested at 12%, and the interest is compounded 4 times a year. 4 times a year, that means n is 4. And 12%, so r is 0.12. Remember, we changed the 12% to decimal. So we have 1 plus 0.12, and we're dividing by 4. And the exponent is n, that's 4, times the number of years, 8 years, so t is 8. Oh, sorry, n is 4. Let me put a 4 over here. So we're going to use our calculator to figure out This is 0.12 divided by 4 is 0.03. 1 plus 0.03 or 1.03 to the 32. Okay, so that would be 1,000. And from the calculator, we get this amount. That's 2.575. All right, so we multiply by 1,000 and we have $2,575. In number 3, we have the same amount, $1,000 at the same rate, 12%, and invested for 8 years again. But this time the interest is compounded continuously, and we want to find the amount after 8 years. So here's our formula. For compounding continuously, we have a different formula. We have the amount is equal to the initial investment, e to the RT, where R is the rate. All right, so in our case, the initial investment is 1,000. The rate R in decimal is 0.12, and the number of years is 8 years. So we're going to figure out, using our calculator, e to the 0.96. 0.96, that's 8 times 0.12. Okay, so we get this value from our calculator. It's usually the function that's above the ln function on most calculators. All right, so let's do that. And I have 2.611. All right, so multiply by 1,000 and we have $2,611. So that should be a little bit more than the amount in the previous example, because we're compounding continuously, and before we were only compounding 4 times a year. All right, in number 5, we want to solve this equation. So we want to write both sides with the same base. Here we have base 3. This is base 3. So we'd like to write this in base 3 as well. And we can do that because 27 is equal to 3 cubed. So let's rewrite. So we have 3 to the 2x plus 1 is equal to, and I'm going to write 3 cubed to the 4x plus 5. And now we have to remember our exponent rule, that if we have a power to a power, we multiply these. So let's do that. Let's open parentheses by multiplying those exponents. So we have 3 to the 12x plus 15. So now we have the same base on both sides. So we can just set the exponents equal to one another. And we end up with this equation. 2x plus 1 is equal to 12x plus 15. Okay, let's subtract 2x from both sides. Subtract 15 from both sides. And now divide by 10. So we have x is equal to minus 14 over 10, or just reduce that, divide top and bottom by 2, minus 7 over 5. In number 6, we want to do the same type of thing. Okay, so let's write both sides in terms of base 5, because 125, that is 5 cubed. All right, now let's write that square root as an exponent 1/2. So we have 1 over 5 to the 3/2. Okay, and now on this side we want to write this as 5 to an exponent, like this. So our exponent would be minus 3/2. So now we see that x is equal to negative 3/2. Number 7, we'll write both sides in terms of base e. So here we have e to the 5x plus 1. And on the right-hand side, we have e to the negative 2. So we have this equation, 5x plus 1 is equal to negative 2. Or 5x is equal to negative 3, x is equal to negative 3 over 5. And then number 8, we want to write both sides in terms of base 7. So here we have 7 to the 5x plus 2, and 1 is equal to 7 to the 0. Remember, anything to the 0 is 1. 5 to the 0 is 1. 4 to the 0 is 1. Except 0 to the 0 is undefined. So equating the exponents, 5x plus 2 is equal to 0. 5x is equal to negative 2. And we have x is equal to negative 2 over 5.